Hello friends, today I'm going to show you how to find the derivative of function with respect to the x. Let me see some examples. The first example is let y is equals to sin x over 1 minus cos x. Find the derivative of the function with respect to x. Therefore, in order to find the derivative of x, we can follow some rules and dy by dx of the function is equal to dy by dx of sin x over 1 minus cos x. From this we can say 1 minus cos x times dy by dx of the denominator function 1 minus cos x. 1 minus, that means firstly the denominator sin x minus sin x times dy by dx of 1 minus cos x over the numerator function the whole square, the whole over 1 minus cos x the whole square. From this we get 1 minus cos x 1 minus cos x times sin x. The derivative of sin x is cos x minus sin x times this function have two functions. The first one is polynomial, the second one is a trigonometric. Therefore, from the rule of addition in derivative, we can rewrite separately. We can derive separately. Therefore, the derivative of 1 is 0 and the derivative of cos x is minus x. We can say that minus sin x times into 0 minus sin x. Therefore, 1 minus cos x times sin x minus sin x, 0 minus the derivative of cos x is minus sin x over 1 minus cos x the whole square. This one is equal to we can distribute the given equation. Therefore, cos x minus cos x square minus sin x times minus sin x times sin x, because minus sin x over 1 minus cos x the whole square. This is equal to cos x. We can rewrite cos x minus cos square x minus sin square x over 1 minus cos x square over 1 minus cos x the whole square. This is equal to cos x is the common one, not minus is the common, cos x minus cos square x plus sin square x over 1 minus cos x the whole square. This one is equal to by the way, this one is plus, and cos square x plus sin square x or sin square x plus cos square x equals to 1. Therefore, cos x minus 1 over 1 minus cos x the whole square, 1 minus cos the whole square. This one is equal to minus into 1 minus cos x. We can rewrite in such form over 1 minus cos x the whole square, 1 minus cos x the whole square. This one is since we have a common term, therefore we can cancel each other. We get minus 1 over 1 minus cos x. This is the derivative of the function with respect to x, or the first derivative of the function, or the limit of the function with respect to x. The second example is y is equal to x squared plus 4 over cos x, polynomial function over trig function. Similarly, we can see that dy by dx of is equal to dy by dx of x squared plus 4 over cos x. This is equal to cos x dy by dx of x squared plus 4 minus the first function times the derivative of the second order denominator x squared plus 4 times dy by dx of cos x, dy by dx of cos x over the denominator square cos x the whole square. This one is equal to cos x times 2x, that means 2x cos x minus x squared plus 4 times minus sin x over cos x the whole square, cos square x. This one is equal to 2x cos x minus x plus x squared plus 4 times sin x over cos x the whole square. Since they have the common denominator, we can separate the denominator separately. We can write separately. Therefore, we get 2x cos x over cos x square plus x squared plus 4 times sin x over cos x the whole square. Now cos x times 1 cos x time cancelled by 1 cos x over, we get 2x over cos x plus x squared plus 4 sin x over cos x times 1 over cos x. We can rewrite in such a way. Therefore, x squared plus 4 times sin x over cos x times 1 over cos x. As you remember, 1 over cos x is sec x. Therefore, 2x sec x plus x squared plus 4 sin x over cos x, which means tan x times 1 over cos x is sec x. Therefore, the derivative of the function of f with respect to the x is 2x sec x plus x squared plus 4 tan x sec x. This is the function of the value of it is the derivative. Its first derivative of the function with respect to x, we get this value. The third example is derivative with derivative functions with operation multiplication of a function. Therefore, to find the derivative of the function, simply we say dy by dx is equal to d by dx of the first function e raised dx times cos x plus x. Therefore, you can derive separately d by dx of e raised dx cos x plus d by dx of x. This is equal to d by dx of since this is the product of the function, by applying the multiplication rule, d by dx of e raised dx, d by dx of e raised dx cos x plus e raised dx times d by dx of cos x plus d by dx of x, d by dx of x. From this we get the derivative of e raised x, since it is exponential function, e raised x cos x plus it is this, the derivative of cos x is minus sin x, it is x times minus sin x plus 1. That means the derivative of x is 1. This gives us e raised to x cos x minus e raised to x sin x plus 1. This is equal to e raised to x into cos x minus e raised to x sin x plus 1. This is the derivative of the function with respect to x. E raised to x into cos x minus sin x plus 1 is the derivative function e raised to x cos x plus x. Thank you.